Bismillahirrahmanirrahim. In this lecture, we are solving problem 6 from HVAC course, heating, ventilation, and air conditioning. So, the statement is a bedroom has length, width, and height of 16 feet, 14 feet, and 10 feet. So, given data length of bedroom length is equal to 16 feet, which is equal to 4.88 meter. 4.88 meter. Second is width is equal to 14 feet, which is equal to 4.27 meter. And height h is equal to 10 feet, which is equal to 3.05 meter. And the south facing wall of 16 feet length is 16 feet, and we know that the height is 10 feet. So area of one wall, area of south wall is equal to 16 feet multiplied by 10 feet, because height is 10 feet and 3.05 meter. So which is equal to 160 square feet, and in square meter it will be equal to 14.88 square meter. The south wall is exposed to solar radiation with cooling load temperature difference of 15 degree. Cooling load temperature difference. Cooling load CLTD between outside and inside of the wall is equal to 15 degree. This is difference, so we can write this difference as 15 Kelvin as well. Now has 3 glass window of total area. There are 3 windows in the bedroom, and total area of 3 window is 16 square feet or 4.88 square meter. So area of 3 windows, after addition the area of 3 windows, finally it is 4.88 square meter. Shading coefficient is equal to 1. Shading coefficient is denoted by SC is equal to 1, and total solar heat gain factor is equal to 100 watt per square meter. The outside air dry bulb temperature is 45 degrees centigrade, and specific humidity is 0.015. Outside temperature is 40 degrees centigrade, and outside humidity is equal to 0.015 kilogram of water vapor per kilogram of dry air. And inside temperature is 0. Here is 40 and 0 specific infiltrating to the room with a flow rate of 0.018 watt per meter cube per second. Volume flow rate is equal to 0.018 meter cube per second. Here is the outside air dry bulb temperature of 40 degrees centigrade and 0.015 kilogram specific humidity. Now here there is some missing in the problem. The inside temperature. I'm checking some values which is missing here. In the problem statement there is a missing. So the outside air dry bulb purity 0. The humidity is infiltrating with 0.08. The room has 8 bulbs with the two wall of 14 feet. It is in the last of the paragraph. These values are in the last of the paragraph. This is if the room is to be maintained at 25 degrees centigrade. This is inside temperature and specific humidity of 0.01. This is not missing but given at the end. T inside is equal to 25 degrees centigrade and specific humidity inside the room is 0.011 meter cube per kg. The room has 8 bulbs. Each of 15 watt capacity are used. Total number of bulbs is equal to 8 and capacity of one bulb. Capacity of one bulb is equal to 15 watt. It means that total watt is 15 multiplied by 8, which is equal to 120 watt. With three factor: usage factor, ballast factor, and CLF cooling load factor is equal to 1. Usage factor is equal to ballast factor is equal to cooling load factor is equal to 1. This is supposition. Two walls of 14 feet width have no temperature of difference on both sides. It means that we will calculate only the load calculation for two walls, and there is no heat transfer from other two walls. So we will calculate load calculation for the two walls, north and south wall. North heat transfer is from north and south wall. Heat transfer is from north and south wall, and no heat transfer from south and east wall. And area of north wall is 14.88 square meter. It is given in the start, and area of south wall is equal to 14.88 square meter. So this is A1, this is A2. Total area will be 2 multiplied by A or A1 plus A2. A1 plus A2. And CLTD will of 15 already given. If the room is to be maintained in 25, calculate the following load: fenestration load, infiltration load, both sensible and latent. Calculate number 1 fenestration load. Load calculation from windows. Fenestration load. Number 2 infiltration load. Infiltration load. Infiltration both sensible plus latent. and HFG latent heat of vaporization is given to us as 2501 kilojoule per kg. 2501 kilojoule per kg, and in joule per kg it is equal to multiply by 1000, 2501 000 joule per kilogram. Number 3, lighting load. Lighting load number 4, load through walls, Q through walls, and overall heat transfer is given to us as 0.21 watt per meter square per kilo. And last, total load, find total load. So now we start solution. In solution, first we solve part number 1. Q of windows. Fenestration load heat transfer through windows or cooling load through windows. So formula for this Q load through windows is equal to area multiplied by solar heat gain factor. Area multiplied by solar heat gain factor multiplied by shading coefficient. So area of the window, this is not area of the wall, but this is area of the window. So area of the window is given to us for all three windows, 3 class window of total area 4.88 square meter. This is area of the 3 windows. So this is not 14, but this is 4.88 square meter multiplied by a single heat gain factor is equal to 100. This is given to us 100 watt per square meter, and shading coefficient is equal to 1. Meter square will be cancelled with and with meter square, and Q window, this is sensible heat. S means sensible. Q window sensible is equal to 4.88 multiplied by 100 is equal to 488 watt. Now part number 2, infiltration मालूम कर ले. infiltration load sensible hour later. तो infiltration load sensible plus later. So infiltration load sensible is equal to m dot mass flow rate of dry air into Cp plus per dry air outside temperature minus inside temperature. So first we find m dot dA. For this V is given to us m dot dA total volume divided by specific volume. Specific volume is equal to total volume but a mass. Similarly, m dot is equal to total volume divided by V. Total V is given to us as 0.018 meter cube per second, and specific volume we can find this from steam table or from psychometric chart. Psychometric chart at temperature, dry bulb temperature at 40 degrees centigrade, and specific humidity is equal to 0.015 kilogram of water vapor per kilogram of dry air. So at these value find specific volume, which is equal to 0.83 meter cube per kg. So put this value here, 0.83 meter cube per kg. So this meter cube will be cancelled with this meter cube, and mass flow rate will be equal to 0.018 divided by 0.83 is 0.0217 kilogram of dry air per second, kilogram per second. Now Q sensible is equal to, this is for infiltration, Q sensible is m dot d mda, so the value of mda is equal to 0.0217 kilogram per second. Cp per air is equal to 1005 joule per kilogram per Kelvin, and outside temperature is 40 minus 15 and difference is equal to Kelvin. So this Kelvin will be cancelled with this Kelvin, kilogram will be cancelled with kilogram, joule per second is equal to watt. Difference of 40 and this is 25 and 25 is 15, 15 multiplied by 1005 multiplied by this value. So sensible load per infiltration is equal to 327 watt. This is sensible. Now Qlatent per infiltration is equal to m dot dA specific humidity outside minus specific humidity inside and 2 latent heat of vaporization which is given to us in the given data. So Q dot L is equal to m dot dA is equal to 0.0217 kilogram per second. Outside humidity is 0.015 minus 0.011 and the value of HFG is given to us, which is HFG is given to us, which is equal to 2501000 joule per kg. 2501000 joule per kg. So this kg will be cancelled with this kg. Simplify this. So Q dot latent is equal to 217 watt. This is equal to 217 watt. Now this is the solution of part B. Now we are solving part number C or part number 3. So Qlighting is required. So Qlighting is equal to n number of bulb multiplied by load of one bulb multiplied by usage factor multiplied by BF second factor, ballast factor and cooling load factor. So number of bulbs are 8, load of one bulb is 15 watt and all these factors are assumed as 1. So Qlighting is equal to 120 watt. Part number 4 or part number D is calculate the cooling load through walls. Cooling load through walls. So Q walls is equal to, there are two walls, so area multiplied by, formula is area multiplied by overall heat transfer multiplied by cooling load temperature difference. So area per two wall is 2 multiplied by 14.88 square meter. There is no heat transfer from other two walls. Overall heat transfer coefficient is 0.21 watt per meter square per Kelvin. Temperature difference is 15 degrees centigrade and we can write this difference as 15 Kelvin. Kelvin will be cancelled with Kelvin, meter square will be cancelled with meter square. So Q through walls is equal to 94 watt and this is sensible. Now it is required to find the total load at the last point, total load. So first we find total sensible load. Total sensible load is equal to first per in first part per window is put 88 watt or 88 watt sensible. Second part infiltration is 327 watt, and third per lighting is 120 watt, and fourth per walls is 94 watt. So total sensible load is equal to 1029 watt, and total latent load is equal to, this is just only for infiltration, 217 watt. So total load is equal to total sensible load plus total latent load, so which is equal to 1029 watt plus 217 watt. So total load is equal to 1246 watt, and hence the problem is solved. And for more videos, please like and subscribe my YouTube channel and share with your friends. Thank you.